Hello everyone, I hope you're all having a wonderful day. I'm very excited that you decide to look at the review video on one of our favorite topics, properties of exponents. Yay! Alright guys, so I know that this is a difficult topic for a lot of us, but I promise you if you guys just remember the property rules, it should hopefully become way easier for you. Alright, so for number one, I see we're multiplying 4x cubed times 9x to the 11th. Alright, so first thing I realize is that we're multiplying here. And see the 4 and the 9, those are just regular numbers out in front of our variable. So we can multiply 4 and 9 together like normal. Right? We know 4 times 9 is 36. But what's different here, the power rule that we have to remember for the exponents is that when we multiply, we add the exponents. So since 3 plus 11 gives us 14, my exponent is going to be 14. Right, so again, multiplying, we multiplied 4 times 9 to get 36, but when multiplying, you add the exponents. So 3 plus 11 gave us our exponent of 14. All right, for number 2, you guys, right away I noticed that we're dividing. So again, we just have to remember the property rule when dividing. We subtract the exponents, right? So we still have our variable of y, but when we subtract negative 7 minus 3, that gives us negative 10. So our new exponent is negative 10, right? But from here, we're actually not done, right? We have to remember that negative exponents are not simplified all the way, right? This is not our final answer. In order to get our final answer in simplest form, right, we need to make the exponent positive. And remember, we do that by putting everything under 1. So here, I still have my y to the 10th, but notice now it's a positive 10. Because again, that action of putting everything under 1 makes our exponent become positive. Right, for number 3, the first thing I notice are the parentheses. Alright guys, and by now, I hope that we recognize, right, when we see parentheses, we want to distribute. I know this looks a little different, right? Normally we would see the 2 in front of the parentheses, but it's the same idea. We have parentheses, so we are going to distribute, but in this case, what we're distributing is the exponent of 2. Right? Since this little 2 is an exponent, that is how we distribute it to each of our numbers. So what that means is that the 5 is going to get the little 2, and the m is going to get the little 2. Right? We distributed that 2 to each term in the parentheses, just like we always do when distributing. Right? From here we can simplify this still, because we know 5 squared is 5 times 5, which is 25. So our final answer is 25m squared. Right, same exact idea for number 4. We have parentheses, which means I'm going to have to distribute the exponent of 3 to each of those terms. So that means j is going to get the little 3, as well as 4 on the bottom of our fraction is going to get the 3 as well. Right, notice j over 4 is still there. Right, it's staying exactly the same, but we distributed that little 3 to both the j and the 4. Again, there's still one more thing we can do. J to the third, j cubed is j cubed, right? That's a variable, that is what it is. But we know 4 cubed is 4 times 4 times 4, and that value is 64. So our final answer is j cubed over 64. Right, and those are the basic properties here that you'll see. Right? When we multiply, we add the exponents. When we divide, we subtract the exponents. When we see parentheses, we distribute the exponent. Alright, so when we see problems like number 5, I understand this one is definitely more of a challenge to go through, but we do know how to do all of it already because it just combines all of those other properties we've seen here. Alright, so when starting number 5, think of order of operations, PEMDAS. Right? We know that we like to deal with exponents before we multiply. So I'm going to leave that 5x to the 4th alone, and I'm going to focus on getting rid of this little 2 outside of the parentheses. And we just talked about that in examples 3 and 4, right? This now looks, just this part, looks exactly like example 3. So what we're going to do is we're going to distribute that 2 to each term in the parentheses. Right? And please realize this 2 is only touching this set of parentheses. So we're just distributing it to what's in this set of parentheses, the 3 and the x to the 5th. Right? So we're saying the 3 is going to get the little 2. And when we give x the little 2, that's another rule. A power to a power means we multiply. So there I would multiply 5 times 2 to get my new exponent on x. Alright, so now we have some stuff in this parentheses we can simplify. So 5x to the 4 stays the same. But now we can simplify 3 squared is 3 times 3, which gives us 9. And then again, x over here, we had to multiply those exponents together. So now we get x to the 10th. Alright guys, last step. What we have here now looks exactly like number 1. Right, we already discussed when we're multiplying here, because that's what we're doing. 2 things right next to each other mean we're multiplying. Right, so we're going to multiply 5 times 9 like normal, which gives us 45. And again, we've already discussed when we're multiplying, we add the exponents. So again, we're going to get an exponent of 14, like in example number 1, because we're adding 4 plus 10 to give us that exponent of 14. And so I promise you every single one of these problems that looks like number 5 goes through those exact same steps. Right? We always start by distributing that outermost exponent. Right? And then from there we simplified that distribution. Right? When we did 3 squared, we simplified it to 9. And then here when we have our power to a power, we multiply 5 times 2 to get our new exponent of 10 there. Right? And again, on that last step is just like example number 1. We multiplied 5 times 9 to give us 45, and we added the exponents 4 plus 10 to get 14. All right, and lastly, guys, number 6, this should be so easy because, again, anything to the 0 power is always, I hope you guys just said it, it's always 1. Right? Anything to the 0 power is only 1, always 1. It doesn't matter what it is. This could have been a fraction. If it was 37 over x. If it's to the 0 power, anything to the 0 power will always give you 1. Alright, so hopefully this review of your exponent properties was helpful. Right, again, this will kind of go along with your skill review number 1 worksheet that has already been assigned to you guys. Alright, but this is also just a great review in general too. So again, hopefully this was helpful. Hopefully you guys are doing great online with your learning. If you ever need anything, of course, message me through Edsby. Alright, but I hope you guys have a wonderful rest of your day. Bye!